Friends, welcome to weekly lectures. In this session, we are discussing the direct and reciprocal lattice in crystal lattice. Coming to the direct and indirect lattice, we have in direct lattice, any vector is spanned over the real space. And any lattice vector R can be written as n1 a1 plus n2 a2 plus n3 times a3. Coming to the reciprocal lattice, it is spanned over k space, or it is also called inverse space, and any vector G can be written as h b1 plus k times b2 plus L times b3, where h, k and L are Miller indices. Now here in this reciprocal lattice, G represents all parallel planes. Parallel planes as we have represented by H, K and L, and the magnitude of G is equal to root of H square plus K square plus L square. Coming to the real space, we have three vectors a1, a2 and a3, and the vector is given by n1, n2, n3. So that is n1 times a1, n2 times a2 and n3 times a3. So this is what is given represented by vector r. Now this is in real space. And coming to the reciprocal space or the k space or inverse space, here we have b1, b2 and b3. Any point represent h, k and L, and any vector that is G is given by G is equal to hb1 plus kb2 plus L times b3. In direct lattice, plane is given by Miller indices. Plane is given by Miller indices. That means if we have the direct lattice something like this, if this is the vector R, in all points you have a plane which is perpendicular to R and parallel to each line. So this represent H, K, L for the corresponding planes, and here you have A1, A2 and A3, and the distance of the separation DHKL is given by, if it is a cube, it is A divided by root of H square plus K square plus L square. But in reciprocal lattice, there's a small difference. dhkl as given by 2 pi by root of h square plus k square plus l square, and we already know that this h square plus k square plus l square is nothing but the magnitude of g, so that gives dhkl equal to 2 pi divided by magnitude of g. Let's look into few notes that these are set of parallel planes in a direct lattice is represented by the reciprocal lattice vector g. That is, the in a direct lattice, if the all parallel planes, that means all the parallel planes in the direct lattice is represented by a single reciprocal lattice vector g in the inverse lattice. Okay, so g is equal to, as we have discussed, hb1 plus kb2 plus lb3. Fine. Now again one more note, g is perpendicular to hkl plane. dhkl is equal to 2 pi by magnitude of g. Now here we have direct lattice, and on the right let us take the reciprocal lattice. And the direct lattice we have A1, A2 and A3, while in the reciprocal lattice we have B1, B2 and B3. Volume in the real space is given by volume in real space. Direct lattice is nothing but it is spanned out the real values, so volume as V is equal to A1 dot A2 cross A3. Okay. So similarly corresponding values of B1 is given by 2 pi into A2 cross A3 divided by the volume, that is A1 dot A2 cross A3. So now, and what about B2? B2 equal to 2 pi times, so B2, so it will be A3 cross A1 divided by volume. Similarly, B3 will be equal to 2 pi into A1 cross A2 divided by volume. Volume is nothing but A1 dot A2 cross A3. Now please remember this value. And what are B1, B2 and B3? These are reciprocal lattice vectors. B1, B2, B3 are reciprocal lattice vectors. So if we are given A1, A2, A3, that is the lattice vectors in a direct lattice, you can find out the corresponding values of reciprocal lattice vector, that is B1, B2, B3, using the formula this. Okay. Here we have a note that the lattice vector in the real space is not given by the value such scale, is not given by the HKL values, which means the vector R is not a function of R of HKL. So this is what we have to keep in mind. And another note is the plane, the lattice plane is represented by HKL. As we know, the formula goes like this: hx by a plus ky by b plus lz by c equal to 1. So this is the lattice plane which is represented by HK. While in direct lattice, we know the lattice vector R is given by n1 a1 plus n2 a2 plus n3 a3. And coming to the reciprocal lattice, in reciprocal lattice, vector is given by reciprocal lattice, vector is given by HKL, that is G is equal to G of H, K and L. Now we know how G is represented by G is equal to H times B1 plus K times B2 plus L times B3, where B1, B2 and B3 are lattice vectors. In that is reciprocal lattice vectors. Now let us see different structures, cubic structures in reciprocal lattice. Now we will start with the simple cubic. In simple cubic, it is a primitive structure. Primitive means the number of atoms is equal to 1, and the corresponding values or the vectors are a1 equal to ax cap, a2 equal to ay cap, and a3 equal to az cap. These are vectors, lattice vectors. Now from here you can write the volume of real space, because this is defined in real space. So we will write the volume as v equal to a cube. Okay. Now in reciprocal lattice vectors, or in reciprocal lattice, we have the corresponding values of b1, b2, b3 with respect to a1, a2 and a3. Now we know that the values are given by b1 as equal to 2 pi times a2 cross a3 divided by a1 dot a2 cross a3. Similarly, we have b1 which is equal to 2 pi into b2 which is equal to a3 cross a1 by the a1 dot a2 cross a3 is nothing but the volume, so we will write it as volume, and b3 equal to 2 pi times a1 cross a2 by the volume. So by applying b1, b2 and b3 formula, that is, give a1 equal to ax cap, a2 equal to ay cap, and a3 equal to az cap, we will get b1 as equal to 2 pi by a into x cap, b2 equal to 2 pi by a into y cap, b3 equal to 2 pi by a into z cap. Now you can see this is very similar to a1, a2 and a3, because some constant into x cap, some constant into y cap, and some constant into z cap. So we can write the reciprocal lattice of simple cubic is simple cubic itself. Okay, so this is the inference that we are making out of this. Coming to the body centered cubic crystal, body centered cubic crystal, we have the number of atoms. Just we will write number of atoms equal to 2. Okay. And the volume as equal to a cube by 2. Okay. Now the vectors a1 is equal to a by 2 into minus x cap plus y cap plus z cap, a2 a by 2 into x cap minus y cap plus z cap, a3 which is equal to a by 2 into x cap plus y cap plus z cap. Now a1, a2, a3 are the lattice parameters along this x direction, y direction and z direction. So the lattice vectors in reciprocal lattice, let me write the reciprocal lattice parameters or lattice vectors are given by b1 is equal to 2 pi by a into y cap plus z cap, b2 equal to 2 pi by a into x cap plus z cap or z cap plus x cap, b3 equal to 2 pi by a into x cap plus y cap. So this reciprocal lattice vector b1, b2 and b3 are similar to the direct lattice vector of direct lattice vectors of face centered cubic. That is FCC. So you can write here the reciprocal lattice vectors of body centered cubic is FCC. Okay. Now coming to the face centered cubic. The vector a1, that is the direct lattice, is a by 2 into y cap plus z cap, a2 equal to a by 2 into z cap plus x cap, a3 equal to a by 2 into x cap plus y cap. So these are the lattice vectors. Okay. Now coming to the reciprocal lattice vector of face centered cubic. Before going to the reciprocal lattice vector, let us define the volume of the unit cell here. Volume equal to a cube by 4, where 4 is number of atoms in face centered cubic as 4. So the reciprocal lattice vectors are given by b1 equal to 2 pi by a into minus x cap plus y cap plus z cap, b2 equal to 2 pi by a into x cap minus y cap plus z cap, b3 equal to 2 pi by a into x cap plus y cap minus z cap. So this b1, b2 and b3 are similar to that of the lattice vectors in body centered cubic. So we can write the reciprocal lattice vectors of face centered cubic crystal are direct lattice vector of vectors, or is, you can write is uh, direct lattice vector in BCC, body centered cubic. I mean, it's not the exact number, but it is the lattice vectors are in that of BCC. Okay. Small note, uh, uh, corresponding to the hexagonal closed pack structure. The reciprocal lattice of HCP is HCP itself. For HCP, we will write A1 as equal to root 3 by 2 times AX cap plus A by 2 times Y cap. A2 as equal to root 3 by 2 times AX cap plus A by 2 times Y cap. A3 is equal to root 3 by 2 times, sorry, it's A3 equal to C Z cap. So here in HCP we have A, B and C, where A equal to B, not equal to C. Volume of the HCP is root 3 by 2 times A square C. Right.